Hello, how are you today, everyone? So today our assignment for this Friday Fun Lab week 9 for data mining is um, we have to run several codes on k-means, hierarchical cluster, and dbScan algorithms on our assigned group datasets. So my dataset is insurance dataset. So I have run the codes, and it took me a lot of work, but after that, I got successful, and I'm happy for it. So let's talk about the codes that I have run and my work here. All right, so first I have imported all the like packages, pandas, numpy, and mat plotlib, and then first we're gonna discuss the question, and then we're gonna discuss both the answers. So for the first question, we have to pre-process our data sets, remove the class attributes, select only the important attributes which to run important algorithms if necessary, and convert to the numeric attribute format, which I have done it. So in the first question, we imported a data set insurance.csv. Then as mentioned in the question, we adopt the class attribute, it's here, and then dropping other attributes, and we can see here it's the data over here, and you can see like it's yes and no, all of them. And then we converted the data attribute to numeric from smoker to numeric one. You can see it's numerical, and then as demanded in the question, we have to standardize the features to follow the normal distribution for a better and faster classify results. So we have transformed the data here, as we have also done that one in our other previous assignments. We can see array here, and standard scalar is minus 1.438 array to 0.453, and we signed the scaled data to our data frame and use the index and column to keep original indices and column names, which we can see that one. So we done with the remove the classifier and select only the important attributes to run the algorithm. We've done with the question number one. Then we have to use the elbow method to determine the optimal k for k-mean. So the second question was the elbow method. My maximum k was 10. I selected from 1 to 10 here, and we see here it's max initiator 500, initiate 100, and random state is equal to 0, and maximum k is equal to 10. Here it is. You can see here our k, the optimal value for k is 5, because after that we can see it's getting dropped now, and here it is, and we make the cluster k is equal to 5, and it fits to the model to the data age, bmi, and smoker. So this is a visualization for I've plot for figure, and this is a figure for visualization for age, bmi, and smoker. There are three different clusters in it: age, bmi, and smoker, and different color, 1, 2, 3, 4, 5 colors for these one. As we can see, five clusters was there, k is equal to 5. And then we see question number 3 is for hierarchical clustering algorithms. So run a hierarchical clustering algorithm on your dataset and generate a visualization of your result. Okay, so question number 3 is here. So uh, I've run the hierarchical clustering from first we imported the algorithm clusterings running hierarchical clustering. So link is equal to word, and the code was run here. You can see here. Then the cluster labels array 120001. Then the visualization here, it's import into tools, and for x equal to 1, and for right and left is equal to 0. You can see this is the nodes for this one. So let's see the visualization here for hierarchical cluster. Here it is, the diagram. So diagram it is children of hierarchical cluster, and children is equal to model of children, and number of observations. You can see here our dendrogram dendrogram diagram here for the visualization. Yeah, it's and radical diagram. Then we can move towards our, we have to run the db scan on our dataset and generate a visualization of our results. All right, so here it is db scan. Question number 4, db scan. Then imported the db scan model first, matrix matplotlib, running db scan, eps is equal to 0.25, minimum sample is equal to 12, and here it is, you can see here it was run. Then the labels were run for to see 1 to -1, number of clusters in labels is from 1 to -1, else 0, and estimated number of clusters came up to 2. So this is the number of noise points which it has done. Then the visualization for our clusters, 2 clusters. Which one is small? You can see here 2 clusters. Let's set it up 2 clusters here. So it was also run on our smoker BMI and age because we prioritize our results. So question number 5 was determine the quality of each result and compare the output. Show which algorithm works best and explain why you think that is. So I have the result over here for me. The I believe, and it's pretty sure it's seen there, the result of k-mean clustering is the best with 3 clearly distinguished cluster. So the results of hierarchical cluster and db scan have 2 clusters which are not very good because it can, the sample from both clusters are intermixed to some extent with unclear boundaries. So in my opinion, the k-mean clustering algorithms works the best because it produces 3 clusters with clear boundaries and no intermixing. And so obviously 3 clusters gonna give us a good we can say explanation to understand the situation and to understand the results. The more the results will be, the better the results will be in positive. So meaning of data for question number 6, we have to indicate our data, like what is the meaning of data. So here it is. For our class attribute is charges, which has to be bucketed into 5 classes to create categories. Hence number of classes in class attribute is equal to 5, number of clusters in k-mean is equal to 5, number of clusters in hierarchical clustering is equal to 2, number of clusters in db scan is equal to, as we can see, we have done all these things we can see here. So the number of classes in the class attribute is equal to the number of clusters in k-means and greater than the others. In an ideal case, the number of clusters is equal to the number of classes, and in the worst case scenario, the number of clusters is equal to the number of samples. So the k-means clustering is perfect algorithm of our data because it can clearly divide the sample into 5 clusters with boundaries and hence aid in predicting the class of any new samples. So I believe so. I have done my job here for today assignment, and this is the one. Thank you so much.